All right, guys, we have one final volume formula to talk about today. So there's a volume of a sphere. We're going to write that in. The volume of a sphere is equal to 4/3 pi r cubed. So a sphere is just a three-dimensional, like a ball, like a circle, but we're going to find the sphere whose radius is 6 inches. So if I find it in terms of pi, I'm literally just plugging into our formula. Volume equals 4/3 pi, radius was said to be 6, cubed. Now when I do this in terms of pi, I don't plug pi into my calculator. Okay, I'm going to have alpha y equals 4/3 6 cubed, and we get 288. So that is 288 pi inches cubed. Now over here in part B, if it says to round to the nearest cubic inch, that's different. Now we take that 288 and we multiply it by pi. So we get 905 when we round to the nearest cubic inch. Okay, so that being said, a sphere has a great circle, which is really known as this kind of cross section in here. Great circle is just like that biggest circle you can get out of a sphere. So it cuts through the diameter. The circumference is 95 centimeters. What is the closest volume to the sphere? So this circumference is 95. Think back, circumference is equal to pi times diameter. So we can calculate the diameter here by taking 95 and we'll divide pi from it. So I'm going to have 95 divided by pi. Now that's my diameter. We need the radius, so I'm going to divide this by 2. Now without rounding, I'm going to plug into my volume by doing alpha y equals 4/3 second pi. And I'm just going to plug that in by hitting the up arrow, have that whole thing raised to the third power. So again, I love to let my calculator do the work for me. I don't have to retype this. I don't want to round too soon, so I'm just going to plug it in like this. And then we're going to pick the one that is closest to 14,478. Choice 4. Okay, but don't be afraid to let the calculator do the work for you there. That's totally fine. Okay, the largest sphere possible is placed in a cube that has this length of 8 centimeters each. What percent of the cube's volume does the sphere occupy? So, if it's the largest possible sphere, here's one side. My diameter is going to match that. Okay, so there's two things we have to find here. First, we need the volume of the cube, which is just going to be 8 times 8 times 8. Okay, so that's our cube. So we get 512 centimeters cubed. Now, the sphere, 4/3 pi, r, if this is the diameter 8, r is going to be 4 cubed. Okay. Now, we're trying to find the percent. So think about a percent of something occupying it. The total amount possible is what the cube is, the 512. So it's out of that potentially. We want to know how much of the space is filled. So we're going to take the number we just got and we're going to divide it by 512, right? Like if you were calculating what you got on a test, like if you got 30 out of 32 points, that's how you calculate percent. So we're going to take that number that's already in here, or 82, excuse me, I was writing it wrong, divided by the 512. And then I multiply it by 100 because it's the total percent. So it's going to be 52%. So 52% of the cube is filled. Okay, now we have a grain silo that stores corn and can pack a density of 16 pounds per cubic foot. The silo is shaped like a cylinder along with a hemisphere on the same radius on top of the cylinder as shown. So first determine the volume to the nearest cubic foot. So we're going to have to do two parts here again. So let's find the cylinder first. So the volume of a cylinder is pi r squared h. R is 5, and the height is 15. I'm not going to put it all into the calculator just yet. I'm going to have 5 squared, which is 25, times 15, 375 pi. Now, the hemisphere is going to be the same as the formula for a sphere, but hemisphere means we cut it in half. So we're going to have 4/3 pi radius cubed divided by 2. So I'm going to plug all of that into my calculator. So alpha y equals 4/3 pi 5 cubed. That's a sphere divided by 2. Now that's my hemisphere. Now remind yourselves that we have to combine it with the first part, the cylinder. So I'm going to add on the 375 pi. Okay, and when I round to the nearest cubic foot, we're going to get 1,440 feet. Okay, so how many tons of corn can the silo hold if there are 2,000 pounds per ton? So we have two conversions to keep in mind here. So we have to remind ourselves about the density over here, 16 pounds per cubic foot. And then we want to convert it to tons after. So with that density, we're trying to find the mass again. So remember our density formula. You can use this triangle to help you, dmv. So we're looking for the mass. We have we have the volume now. We have the density. So we're going to multiply. So we get 23,040. Now remember, that's pounds because it was 16 pounds per cubic foot. So those two went together. We want to know how many tons we can hold. So there's 2,000 pounds per ton. So in this case, we're going to divide by 2,000 because when I do that, I'd be dividing the pounds out and canceling those. And then I would end up with my answer in tons. So we'll take this number, divide it by 2,000, and we get 11.52, which we want to round to the nearest tenth, so 11.5 tons. Okay, last question here. So this one's a big one. You have a bunch of different parts in here. We have Nico got the jumbo ice cream cone at the Dutchess County Fair. The amount of ice cream can be modeled by using a cone whose height is 12 and radius is 4. You have a hemisphere, which is got a radius of 4. And then you have a full sphere on top of that. Now, we're pretending that this ice cream came out the most beautiful and perfect that it could be. Now, if there are 237 cubic centimeters in a cup and 320 calories per cup of ice cream, how many calories is this treat in the cookie cone itself? It has 85 calories. So what I want you to do is pause the video here, and I want you to do 3 separate volumes. You're going to find the hemisphere, the sphere, the hemisphere, and the cone. So you have to find 3 volumes, and then we'll do these conversions together, or I'll walk you through it. So go ahead and pause. So right now, I have calculated the sphere, the hemisphere, and the cone. So for the sphere, you should have did 4/3 pi 4 to the third, and I got 256 pi over 3 when I simplified. The hemisphere was that same thing, just divided by 2. So you could have left it as 256 pi over 6 or 128 pi over 3. And then the cone was 1/3 pi 4 squared times 12. So I just used the formulas we've used in the previous lessons. And I added all of them up. So I let the calculator do the work for me. And notice I haven't really rounded yet. But the volume of ice cream right now is 603.18578. And it went on to like 9 and some other numbers. I'm giving myself 5 decimal places for now. Now, the question is asking us how many calories this is. One, realistically, I don't want to know. But if we're here, first thing I'm going to convert is I'm getting it out of the centimeters. So there's my cubic centimeters in a cup, right? So we want to figure out how many cups this is. So basically what I'm going to do is take the number that I have, and if I want to get it into 1 cup, I'm going to divide this out, right? Basically what you can think of is if I take this and I stick this over 1, our goal is to cancel out the centimeters here. So that's 237 centimeters cubed for 1 cup. So it's not cross multiplying because there's no equal sign. I'm multiplying it by this. So that's why it's dividing. So I'm going to let the calculator do my work here. I have that number, divide it by the 237. So now we're looking at 2.54508. Okay, so that's cups. And in a cup, it's got 320 calories per cup. So think of that, 320 calories per 1 cup. So now I put the cup on the bottom because, again, I'm trying to cancel out that unit. So now I can be in calories. So I'm going to multiply this time by 320. And so we get the amount of calories, but also they hit you with a little zinger here of don't forget that the cone itself is 85 calories. So we just calculated the amount of the calories in the ice cream. I still have to add in that cone. So we're looking like almost 900 calories for this ice cream. Am I sorry? No, I probably want that ice cream. It's getting warmer. It's okay. But that's how we would calculate that and do those conversions. Okay, guys, thanks so much for watching.